All right, welcome back. For our fourth example, what we're going to look at is multiple functions. So what we have here is we have three functions that are going to define our region. The first is the x-axis. The second is y equals x minus 2. And the third is y equals square root of x. So what we want to do on this is we're just going to go ahead and split this into two completely distinct regions. We're going to split it right there because the area of this will be square root of x minus 0. And the area of this will be square root of x minus 2. So what we need now is we need three boundaries. Well, we know that these first two intersect at 0. So that's the intersection of square root of x and the x-axis. We know that the second two, the x-axis and x minus 2, well, that's the x-intercept, which means that this is at x equals 2. And then the last question that we have is where do square root of x and x minus 2 intersect? And this is a little bit trickier, but we can square both sides and get x equals x squared minus 4x plus 4. 0 equals x squared minus 5x plus 4. And we get x minus 4x minus 1. And so we know that these two curves will intercept at x equals 4 and x equals 1. Obviously, x equals 1 is an extraneous solution. If you think back to what you know about sleeping parabolas versus square root of x, if the square root were a sleeping parabola, it would intersect right there. Since it isn't, it doesn't, which means that the number we care about is x equals 4. So what do we have for our area? Well, we have the integral from 0 to 2 of square root of x dx. Remember that square root of x minus 0, but we don't have to put in the minus 0, plus the integral from 2 to 4 of square root of x minus parentheses x minus 2. Do not forget the parentheses, or that will not be a plus 2. And you could calculate this by doing it using the fundamental theorem of calculus. Not bad practice. I would recommend that you do that when you see it and you can, until you get to the point where you're okay with it. Once you're really good at it, you type it into your calculator. You want to be a little bit careful because the exact answer to this is 10 thirds unit squared. If the question asks you for an exact value, be a little bit careful, because otherwise you're going to get 3.333 units squared, which is perfectly acceptable unless you are asked for the exact value. All right, so this will be a quick video, and I'll be back with the next. My students go ahead and do exercise 9, and I'll be back with an alternative discussion on how we could integrate using y instead of x.